Direct conversion receivers like this one are sensitive to magnetic fields because the fields will induce currents and voltages in the lines between the mixer and the first audio amplifier, or in the mixer itself. There will be current flowing through like that because of the magnetic fields. And this is a problem particularly if one is using two of these kind of receivers together to do correlation measurements. I have had problems with this in my video for Nerds 52, and I show some short sections from that video first. I have set the attenuators on input and output to the maximum attenuation, in total 100 dB, so the signal at 10 MHz is weak here and doesn't contribute to the noise floor at all. So what I see now is the noise floor with no signal. It's obvious that the problem I had, you can see here, it's noise on the audio frequency, because DC is here and the pattern is symmetric with respect to DC. It is not symmetric with respect to the RF carrier, which is here. So I will see if I can find the reason for this. It's really messy right now, and there are many switch power supplies around. So I will spend some time on cleaning this up, and then I will continue with the selective amplifiers. I have rerouted cables, and now it looks like this. The old result here, you can see here, and now it looks like this. So there are spurs, but not the continuous noise that was really annoying for the measurements of Seibert noise. And further, if I look here, I can see here is a spur. It is weak, very hard to see on the average power spectrum, but it's clearly visible in the correlation spectrum here. But I don't see it in the waterfall. But I can change here with the polarization. Means that what I see here now is the other channel, and it's clear the noise level is a little bit higher, but there are spurs in channel 2. And I can look at some other frequency here. Here is a spur, and here is the main signal, 10 MHz. If I look at the DC component here, you can see the center thing goes up and down because there is some functionality of the sound card trying to make the average 0. Then there is 50 Hz on both sides, 150 Hz. And the 10 MHz signal is weak. It's there, but it's weak. If I change for channel 1 instead, like this, there is not much difference. You can see here, the noise is a little bit lower, and the number of spurs is a little bit smaller. So I will show now essentially what I did and how I can verify what I'm doing. Here I have a transformer from an old TV. I can use this to check what current goes through the various cables. One of the major problems I had is the cables to the computer screens I have two screens. I have solved that by twisting the power cable and the data cable on each other. If I look at current through both of them like this, you can see here and here. If I remove part of the transformer, it picks up magnetic fields from the computer. Now, if I look at one of the cables instead, so this is the power cable, then you can see there is a lot of noise. And of course, if I look at the other one, I see the same, because they cancel each other. And it's the same on the power side. I can look at... I should have more hands or someone else to manage the camera. If I hold it like this on the mains cable, well, you can see there was... Now it's in place. And there is a lot of noise, not quite as much as on the screen cables. And I can look at the ground cable here. This one. And it's a lot of things. And then I have, of course, the power cable to the computer screen. Here I have that, and it looks like this. The screen is the most bothersome. Then I can look at all of the cables. Here. And there is almost no problem. And I have done the same on the other computer here. If I look on the two cables to the screen, it is like this. But if I look to only one of them, like this, I have some noise. Not as much as from this screen. And of course, on the other cable, I should see the same. The mains cable of this computer there is a peak around 2 kilohertz, overtones from the mains. The red wire here, it's a thick cable, 10 square millimeters or maybe more, I don't know exactly. It's really thick. And this is the star ground. It's a 3 millimeter thick aluminium sheet, to which I can connect more wires if needed. There is one of these thick wires going away to the setup for noise measurements. And together with the other cables that go there, they form a bunch. So currents flowing this way and the other way, they balance each other and don't generate fields that couple into other wires. I have supplied the power supplies with filters. I'm checking the current through the plus 25 volt supply line, and you can see here it looks quite okay. But it is because I have this filter in place. Now I have disconnected the filter and run a wire from here directly to this cable that goes to the system that I have with the direct conversion receiver. Then what I see is this. There is a lot of noise. So essentially this is the star ground. Here is a bunch of cables. All of them go away to the receive system. Power cables go to these power supplies and that, and also to the oscilloscopes. And the remaining ones go here into the system with two direct conversion receivers and some other stuff. Here is the UADC4, the sound card. And you can see here I have twisted two wires. I can check only one of them here. The white wire. It looks like this. And then I check both of them. And then there is nothing. So I am minimizing loops everywhere to have this current go like this, and it won't couple into these wires, not much. Mains comes through this cable and is routed through this thing, which is a common mode choke made by mu metal, very high permeability, so it has a good attenuation for common mode 50 Hz. That is to isolate the RF instruments, signal generators, network analyzer and spectrum analyzer, so I can connect cables to this without having ground lobes from this star ground. Here is another common mode choke. It's on the USB cable to the Perseus. Here I test the current, the common mode on the coaxial cable from the Perseus. And you can see there is not much here. Now I connected another USB cable without any common mode choke on it, and then I see what you see here. And I suffered from these mains overtones around 2 kHz that come from the USB connector, go through the Perseus and out on the coax all the way to the receive system. I have placed this magnetic probe right on the Schottky mixers of this dual direct conversion receiver, and look at the Linrad screen. Now it's through the UADC4 and there is an amplifier in front of it, so it's a very sensitive system now. If I take out this sensor and just hold it in the air, you can see on the screen here it's significantly worse. So this is a field I have everywhere in the room, and for example here it is very strong. It's the power supplies. They have transformers that generate overtones of 50 Hz. The computer is not that bad. Well, I think, well, it is, and it's noisier also. And the screen, well, It depends on the direction, of course. Anyway, the fields at the receiver are much smaller because I'm not conducting as much current there. So it just experiences the fields that come from some a little bit larger distances. It's just 2 meters from there to there. This is going to be enough for me to do the measurements I am interested in. If it wouldn't be enough, I could move this entire thing with all the cables in a single bunch and place them in the next room. But this is a lot of work and highly impractical for other reasons. So I don't do that. I could also place these power supplies inside copper boxes with thick copper, say 3 millimeters or maybe even a little bit more. But that's also a very unpractical thing. There is a cooling problem, for example, when doing such a thing. Anyway, the main lesson with this video is how you run the cables does matter. Watch out for the currents going to and back from the computer screens on the data cable and on the power supply cable, whether it's 220 volts as for this screen or whether it is 12 volts as for this screen. The power supply for it is sitting there, so I'm running just 12 volts on the way to the screen here. And the noise you see is from the pickup coil I have connected, the field sensor, that transformer thing.